Hello everyone, Galen here, and your next lab is going to be description of motion in one direction. Okay, first I would like to talk about some of the equipment that you will be using. Here is a picture of the Capstone software by Pasco that you will be using to display data from the sensors that will be hooked up to the little box down below known as the interface. If something gets messed up while you're working on your lab today, you can always start over with a fresh screen by, in the upper right hand corner, clicking Open File and choosing the file labeled after today's lab. Here is a picture of the Pasco 550 interface that we use in our labs. It connects the sensors to the Capstone software. The position sensor, which we'll be using today, plugs into ports 1 and 2. Force probes, which we'll be using in a few weeks, plug into A if there is only one, or A and B if two are used. We never use the passport 1 or 2 sockets. This is the ultrasonic position sensor, and when it's working, you'll know it has the audible clicking noise. The yellow plug goes into socket 1 on the interface, and black plug goes into socket 2. If the graphs from the sensor are noisy, you're going to need to adjust the sensor. It's not always going to be perfectly aligned. The first thing you'll notice is on the top is a little slider switch that has a narrow versus wide band. You could try those, or there's a little handle on the side that allows you to adjust the sensor up and down. It kind of rotates around a little bit. Ideally, you would like the gold part of the sensor to be parallel to the surface being measured. Our objectives for this lab are the following. Relate the position versus time graph to the actual motion of an object. Relate the velocity versus time graph to the motion of an object. These first two objectives mean you need to understand what is actually going on and how that relates to the graphs that you're seeing on the computer screen. The other thing you need to be able to do is relate the position versus time graph to the velocity versus time graph. That means when you look at one, can you determine what's going on in the other and vice versa? Okay, this is a position versus time graph, or an X versus T graph. Some things that you'll need to notice are the 0 point, which is for time and distance. The 0 point corresponds to distance with the surface of the motion sensor. Some things to think about. What is the slope when the object is stationary? Notice the stationary point, so let's see here, right here, this guy. What is the slope when an object is speeding up or slowing down? So here we have slowing down, here we have speeding up. What is the difference in slope between steady fast versus steady slow? So we have steady fast and we have steady slow. How are those slopes related to each other and what do they mean? I'm not going to go into that here. That's something that you'll need to think about in today's lab. Here are some velocity versus time graphs, or V versus T. Take note of the different slopes. What's the slope? When is the slope positive? When is the slope negative? When is the slope 0? And what would the graph look like if the velocity is 0? You should be able to be prepared to answer these questions and the ones from the previous slide on the next lab. In the last part of the next lab, you will talk about a strobe diagram or a strobe picture. And what is a strobe picture? A strobe picture is taken with the strobe light, and because the strobe light flashes at consistent time intervals, you're able to see how an object moves. So imagine you bounced a ball across the table. Now imagine that you have a camera beside the table and take a picture every second or a half second. What would it look like if you were to superimpose all of those pictures? You place those pictures on top of each other. This is basically what a strobe diagram is. And here you go. Here is a picture of a ball bouncing using a strobe light. Now, some things to think about. How can you tell when the ball is going faster or when the ball is going slower? That is going to be kind of important to what you're going to need to learn in today's lab. Here we are going to see how a strobe photograph is made. If you are strobe sensitive, you might want to look away, close your eyes, but here we go.